right, so like I said, one of the concepts that next year some of you will be needing to understand is the concept of other numbering systems besides decimal. Decimal is the one that we understand because we've been learning it since we were in preschool or before. All right, so we're going to make some correlations between decimal and other numbering systems. So numbering systems in general have some common concepts. One of them is that a numbering system is based on a radix, or a base number. In the decimal system, the base number is 10. The radix is 10. That means we have 10 numerals or symbols to work with in decimal. I have a theory about that. And I think maybe I've mentioned this to you before. Does anybody remember what my theory is about why decimal is the numbering system we've chosen to use? Rebel, stop.
I was sending it to myself.
It's up on the board. Again, does anybody know what my theory is on why we have chosen the decimal numbering system as opposed to any others? Because, well, why is that? We have 10 digits, right? That we use to manipulate things. So that's my theory. I don't know if it's true or not. But anyway, decimal is the numbering system that the majority of humanity has chosen to use in order to count things. So we are familiar with it. The base is 10. Our symbols are 0 through 9, right? All numbering systems have symbols or numerals that they use. And the number of symbols or numerals that they use is the same as the radix or the base for that numbering system. Okay? All numbering systems use something called positional notation. That means the position of that symbol determines the value of that symbol. So a 9 in the ones column is not the same as a 9 in the millions column, right? They have different values based on their positions. All numbering systems use something called exponents. We know what those are. 10 to the third, right? Means 10 times 10 times 10. All numbering systems use those. So it's the number of times that we multiply that base number by itself. And all numbering systems also have a process of either ignoring or paying attention to zeros depending on where they are. If they are before the number, to the left of the number, we call those leading zeros, and we can ignore those. There's an infinite number of them there, right? We don't say 0, 0, 0, 0, 0, 0, 0, 10. We just say 10, right? But if the 0 is to the right of any other numerals before the decimal point, we do pay attention to those trailing zeros. They make a huge difference in the number. We have to pay attention to trailing zeros. Everybody understand that? These are common concepts, not just in decimal. So, let's look at decimal. So in the decimal system, I already told you that the radix is 10. The numerals are 0 through 9. And here is an example of our positional notation and exponents. So based on the position of the numeral in a decimal number, the value is going to be multiplied by whatever that position value is. Right? Does everybody understand what I just said? And these are the values for those positions because of positional notation and exponents. So when we count in decimal, we always start with 0. And we always start with the furthest position to the right, the one right next to the decimal point. Do you have a question, Jackson? Can you refresh it?
I tried.
Yeah, just try going back. This is why we're doing a trial run, so we can work out the bugs. You get the same thing? Close your browser. While he's doing that, we'll continue. So we always start with 0, and we always start in the position that's closest to the decimal point. What happens here when we get down to this position, this value in that first position? What do we have to do? Let's see. Did you have an answer, Damien? So submit it. Just Damien. So watch this. So here is Damien's answer. You go into the next position, the next column, right? He's right. So what do we have to add in the next column? After this, what do we add in the next column, Blake? You have to use that. Type your answer. By the way, do not like any questions or answers, because then I have 18,000 things show up on my screen. Please don't. Or dislike, either one. Okay, so he says then we add a 1 in the next column and a 0 in that first column, and that's correct. We start over in the first column with 0 again, and then we have a 1 in that next column, the next position, for that whole series, right? That's how we count. All right, keep that in mind. So if I say in this practice slide, everybody look up here, this is how we're doing this. If I say I want a 2 in this column, a 0 in this column, a 1 in this column, and an 8 in this column, we all know what number that is, but here's why. What that means is 2 times 10 to the third plus 0 times 10 squared plus 1 times 10 to the first plus 8 times 10 to the 0. When we add all that together, we get 2018. That's how exponents and positional notation works. Pretty straightforward when we're talking about decimal, right? So now we're going to look at another numbering system. The binary numbering system has a radix of 2. So that means we only have 2 symbols, numerals, 0 and 1. And our positions are based on powers of 2. So any number to the 0 power is 1. Any number to the first is the number itself. And then we just multiply that number times itself, however many times that exponent says, right? So the values of our positions are way different in binary than they are in decimal. And watch what happens when we actually start counting in binary. We have to move over very quickly because all we have are 0 and 1. So remember, Blake's answer to the question is what do we do after we fill all the values for one column? We have to move over. And look how fast we have to move over. Okay? So now we're going to practice. We're going to do the same exact thing because now we're going to convert a binary number into a decimal number that we can recognize. Okay? So I want you to pay attention because I'm going to ask people to answer the question. So if I put a 1 in this column, and a 0 in this column, and a 1 in this column, and a 0 in this column, and a 1 in this column, a 0 in this column, and a 1 in this column. That binary number is 1010101. And I want you to tell me what the decimal equivalent of that number is. All right, Chika, you have to use the interactive presentation to answer it. Yes, just Chike. Yes. Okay. Someone else answer the question. All right, Damien. And there is the answer. Did you want to see it? There's the answer. Okay? So a 1 in this column means 1 times 64, right? A 0 times 32 is 0. 1 times 16, 16. So we got 16 and 64 now. What's that? 80? 0 times 8, 4 times 1. Now we're at 84. 0 times 2, 1 times 1, 85. So pretty clear, right? If I gave you another number, do you think you could answer that question? All right. Thank you for helping me. We'll see how this works.